Have you ever seen a snowflake or a flower? If so, you've seen a fractal. So what are fractals? Fractals are infinite and complex geometric patterns made up of smaller, self-similar patterns. But why are fractals useful? So fractals can be used to identify patterns in nature and understand patterns in nature and science. They can be used in artwork to create complex designs, and they can be used in modern technology such as computer graphics. So how do fractals work? Fractals work when the same shape is added to the shape infinitely. So you might start with a triangle, and then you add another triangle, and then you add another triangle to that, and you infinitely keep adding one more to make a more complex pattern. You can use math to help describe different things in fractals, such as the area of the fractal as it increases and the pattern continues, or the total number of shapes or lines or images in the fractal as the pattern continues, or the number of shapes or lines or images that are added each time the fractal is repeated. So there are 3 different ways you can model different patterns of what's being added, or the area or that kind of thing of the fractals, and that's through now-next equations, geometric series, and functions. Now let's look at the example of Sierpinski's triangle, a famous fractal. In Sierpinski's triangle, a non-shaded triangle facing downwards is added to the middle of the shaded triangles infinitely. The amount of shaded triangles in each iteration of this fractal can be shown in 3 different ways. In the geometric series of p of n equals p of n minus 1 times 3, in the now-next equation of next equals now times 3, and in the exponential function of 3 to the power of x. Fractals are just these amazing, intricate patterns that are just so fascinating because they occur in nature and can be used in artwork and can be used in science to interpret patterns and just see these beautiful patterns being repeated over and over again into intricate designs. And not only that, but they can also be represented by math.